Hello everyone, my name is Victor Stivala of the Product Design program here at Montclair State University, and today I'm excited to present to you my senior thesis project, Mobility. To start, I'd like to tell you about my grandfather, the sole inspiration for this project. He lived with a degenerative muscle disease up until his passing this Easter. His disease required him to use a wheelchair or scooter to traverse this world of ours designed but not for him. On one of his visits, he brought a transfer board. Much like how this woman is using in this video, the product is used by sliding one end of the board under the user and the other end to the destination. At this point, you slide the user across the board to the other seat. This product ended up being really useful, but in one direction. In our attempt to transfer from the chair back to the car, it proved to be just as difficult as without the transfer board at all. The lower height of the wheelchair to the higher height of the car seat made all the difference. And more importantly, this puts in perspective how much my grandmother did for him. As his primary caregiver, my grandmother would perform this transfer day in and day out. This was difficult for just my father and me combined. It's hard to imagine someone with their own health conditions having to do this every single day. But this is not a unique story. 30% of all caregivers are 65 and older with their own health conditions. My intent with this thesis project is to design a wheelchair that maximizes the ease of mobility for the user, facilitate independence, transferability, and caregiver mobility. In my research, I had the opportunity to interview several people from physical trainers to, of course, my grandfather. They all affirmed my idea that the height difference between the two destinations is the most important thing to resolve. To summarize the current problems with the wheelchair, we'll start with the high learning curve. You either become physically fit, rely on caregiver assistance, or struggle. Transferability. The seat height becomes a huge issue. It's either too high or too low. And disability level. For users with higher levels of disability, the wheelchair becomes increasingly more challenging. During my time working on this project, I had the amazing opportunity to work in the facilities here at Montclair State University. My studio space is wall-to-wall of inspiration and concept iterations. I used a vast variety of methods to solve the problems I have illustrated, from prototyping and virtual reality, 3D modeling software, to good old hand sketching. Through countless ideation and refinement, I present to you the next in mobility. The transfer method uses a parallelogram form to lift the seat up and over, performing two solutions in one motion. This action is performed using a linear actuator and gear ratio system to provide the appropriate torque to rotate the transfer pylon and seat while maintaining the seat perpendicular to the ground. The seat rotates at a click of a button and then extends forward, closing the distance between one seat to the other. Inspired by e-bikes, a hub motor is included in each back wheel. This makes the wheelchair accessible to a variety of different disabilities. This design includes a combination of joystick control and push rim control. The hub motor allows you to adjust the power provided to each wheel. This lets the user get exercise as they need it or assistance up hills. And of course, considering the caregiver, a handle is designed into the form on the back to maintain that connection between the caregiver and the individual with the disability. This wheelchair is designed to be manufactured using 3D printed technology. This allows the material to be as light as possible while maintaining maximum strength. This also allows the wheelchair to be custom fitted to each individual. To best visualize this product, a 3D printed model was crafted at 5th scale. Thank you so much for listening to my thesis presentation, and I hope you enjoyed it. If you would like to check out this model for yourself, please follow the QR code provided in this image. It'll bring you to an interactive 3D model that you can view up close.